All right, so the matrix we've got is 1, 1, 0, 1, and we're squaring it. So if this is matrix A, then matrix A squared would be 1, 1, 0, 1 multiplied by 1, 1, 0, 1. Now, when you multiply a matrix, okay, this resultant matrix is going to be a 2 by 2 matrix. And the best way to think of it is that this cell, if you describe its position, it's the first row and the first column, right? So that means in this cell, we have the product of the first row and the first column. This cell is the first row. It's still in that first row, but it's the second column. Here we have the second row first column and the second row second column. Now, I state that up there just so that you know this cell is a product of the first row and the first column. This cell is a product of the first row and the second column. Okay, that's why we make that statement. So let's perform the calculation then. In the first cell, we have the first row times the first column. The first row times the first column. So I'm going to do 1 times 1 plus, so 1 times 1 plus 1 times 0. 1 times 1 plus 1 times 0. Okay, first row, first column, isn't it? First row, first column. Okay, the next one is the first row times the second column. So it's taking that first row and we're multiplying it by the second column. So we're going to have 1 times 1 plus 1 times 1. Okay, onto this cell. The second row multiplied by the first column. The second row multiplied by the first column. So we're going to have 0 times 1. 0, so first row, sorry, second row, first column. 0 times 1 plus 1 times 0. And then lastly, the second row times the second column. 0 times 1 plus 1 times 1. Okay, so let's process that. This is going to be 1, this is going to be 2, this is going to be 0, and this will be 1. Okay, so that's the matrix A squared. Alright, so I said you do need to know how to do this, and it will, because it will pop up when we perform the proof of it in a moment as well. So that's the matrix A squared. Now, I've stated on there, and this is how I'm going to ask it for you in a test. I'm going to say, here's matrix A, given matrix A squared, A3 and A4. Here they are. Here's those following subsequent matrices. Now make a conjecture. And the reason we're doing that is because you don't have your calculator and we don't want you to get bogged down in sort of routine matrix calculations. And if you make a mistake here, it can misinform your conjecture. All right? So let's talk about, now we're going to use our calculator to evaluate, they've written there A3, A4 and A5. They're actually wrong. I was trying to copy a blank matrix across. One cell was wrong anyway. So if we're going to do matrix A to the power of 3, this is the fastest way to do it on your calculator. So pull your calculator out, follow along here. You go to the run map, you go to the main window. You press math, which corresponds with F4. You press mat/vect, which is short for vector, which corresponds with F1. And then you select the 2 by 2 matrix. It's going to bring it up. You input the cells. So you just use your cross arrows, you use your numbers, you input your 1, 1, 0, 1. And then you can raise this to any power. You just bring your cursor after it, make it to the power of 3, to the power of 4, to the power of 5. Okay, and that's going to be the fastest way for you to evaluate those cases using the matrix operations in the calculator. So if we do that, I'll clear this off. If we do that, we'll have matrix A to the 3 is 1, 3, 0, 1. All right, everyone see that on their calculator? Yeah. What do we think A to the 4 will be?
1, 4, 0, 1.
You got this, 1401, and a to the 5, 1501. And so now we can make a conjecture about a to the n. Okay? What if this continues, what's the value of a to the n? So we say something like this: if A is this matrix here, 1, 1, 0, 1, then a to the n will be, alright, so we're saying what's a relationship here? Here's a squared, here's a squared, I rubbed it out. Here's a squared, here's a to the 3, here's a to the 4, here's a to the 5. What's going on? Well, that power is just going there, isn't it? That's the pattern that we're noticing. That's what we're figuring out. We've got good inductive evidence to suppose whatever n is, it's going there. Okay, so then a to the n is this, or n is a positive integer. Okay. So in the test, what's going to happen? They'll say, here's matrix A, here's matrix A squared, a to the 3, a to the 4. Make a conjecture about matrix a to the n. Here you go, make your conjecture. Okay. Now prove that your conjecture is correct by using PMI. So is everyone happy with those steps so far? Alright, remember in the test you'll be given the matrices. You won't use your calculator, you're not allowed your calculator in the first test. You won't have to perform a manual operation for the routine cases, but you will within the proof. So let's get on to that then. And if this is a skill that you think I need to practice just multiplying matrices or something, let me know, or something will go over. So let's go. We've got, this is our proposition, right? So P of n is if A is a 2 by 2 matrix such that we have 1, 1, 0, 1, then a to the n is 1 and 0, 1 for all n is a positive integer. Okay, that's our claim. That's our statement. Remember, we make a statement for a proof always first. Let's test it. Test for n is 1. The left-hand side is just going to be this matrix here. The right-hand side is this here where we have 1 for the n. Left-hand side is equal to the right-hand side, PMI is true. Alright. Assume P of k, or assume which is a to the k, okay, make your assumption for all k is an integer. Positive. Okay. On to the proof. P of k plus 1. The matrix to the power of k plus 1 is equal to the matrix to the power of k multiplied by the matrix. Okay? All we're doing there is we're saying if you have a to the k plus 1, another way you can write it is that it's a to the k times a. That's all we're doing there. Here we've got it collected, then we're splitting it up using those index forms that have the same base. So we've got the matrix to the k plus 1 is the matrix to the k times the matrix to the 1. That's all right? Yep. Okay, and so then we will perform the substitution for our assumption. We assumed that A of K is this. So we can, using P of K, we'll have 1K01, and we're multiplying that by 1101. Okay, so we're performing a square matrix multiplication. I'll make it bigger again so that we can practice these multiplying. So we have 1K01 times 1101. Okay. Now I've said whenever we're multiplying a 2 by 2 matrix, it's just its position. 1, 1, 1, 2, 2, 1, 2, 2. First row, first column, first row, second column, second row, first column. Alright. So the first cell then is the first row times the first column. So 1 times 1 plus K times 0. 1 times 1 plus K times 0. In the second cell, we're going to have the first row times the second column. That's going to be 1 times 1 plus K times 1. Okay, in the third cell, 0 times 1 plus 1 times 0. Alright, that's the second row times the first column. Second row times the first column. And in the last cell, we'll have the second row times the second column, 0 times 1 plus 1 times 1. Now if we evaluate that, we'll have 1, K plus 1, 0 and 1, which is P of K plus 1, off to the moon. Alright, it's true. Because P of 1 is true and P of K plus 1 is true, Don't say that in the test. All right, so are we feeling okay with the matrices ones? Okay, so if this is, I'll pop around and see how we're feeling about it. Can I just point out, I projected this up on Vivi for a reason. So this document, right, this is the subject outline. This is what they give us teachers for Year 11 and Year 12 courses. So it's going to be very transparent. This is everything that we need to learn in order for the exam. Okay, this is what they can ask in the exam. It's what I'm expected to teach. So I'll go through what it says about PMI for you guys. And so you're very welcome to have a read of it. I'll upload it to the OneDrive. It's, you know, it's 51 pages, but it gives you an idea of making sure that we've covered all those bases and so forth. So they've got formal proofs are expected. So if we go through here, we've got divisibility down packed. We've got series and so we've got the sums and more complex series there. So, you know, here's a series that involves a product, 1 times 2 plus 2 times 3 plus 3 times 4 and so forth. Okay, so that's those ones. We've got matrix results. All right, so I think that's the one we just proved just then. All right. We have another product series here, and we have a trig one. Okay, so we're familiar with all of those circumstances. Let me talk about these later 3 points. Now this here, prove the nth derivative. They added this in last year. It's a new addition to the course. Now the reason we're not doing that yet is because you guys haven't learned the chain rule, product rule, and quotient. Oh, you have. Quotient, and so have you. Quotient rule that you'll learn in calculus. So I'm not going to test you on the nth derivative, but it will be something that we learn in preparation for our exam, okay? So it's not something you'll be assessed on, but it's something that we'll make sure we cover before the exam. Similarly, when we're doing complex numbers and we go over de Moivre's theorem, we will do together a few PMI proofs then using complex numbers, but they won't be in your complex numbers test because that's specifically about complex numbers. And then if you look at the last dot point, mathematical induction proofs that use inequalities and recursion are not a formal requirement of the course. So you can see I've said we'll do derivatives later because you guys haven't done chain rule, quotient rule, product rule. We'll do de Moivre's theorem when we're doing complex numbers, and everything else we've touched on. That's what you can expect in the test, right? You'll have one series, one product, one matrix, one trig. that's pretty well it. So any questions about the content of the test? All right, so we've got 10 minutes, up to you how you use this time. I'm gonna pop around and see how you're feeling about the matrices. PMI with factors, I wrote that on the sheet that I printed out as well. I'm not assessing it, it's not stated in the curriculum outline, but we might have a conversation about that in more detail, my thoughts on that in more detail next lesson, I think. So you don't need to worry about it at all at this stage.
What rule?
Okay. Cool.